Hello everybody and welcome to my channel. Today I want to talk a bit about opacity in SwiftUI. First let's talk about UIKit and what's the behavior that I was expecting, because all of this comes from basically a couple of hours of going back and forth and trying different things with UIKit and SwiftUI to better understand how both systems work and differ. So imagine that you have a view with a label. In this case, I'm just saying hello UIKit, which you can see here on the preview. So by the way, I'm just using this UIKit code inside the SwiftUI representable, so I can see it on the preview and I can put it side by side in a bit. Besides that, this is just UIKit code. So I have this label which I add into a view, and that view has a background color, which in this case is gray. Right, so that's what we see here on the right. If I wanted to apply an opacity, I would just have to add a new line here, adding the opacity value of 24, for example, 24%. And when we can see here, it's not totally easy to understand because there is no background here, right? So for that, let's come here and prepare the content view with just a Z tag and putting it a color red, right? So now we have all this bit red, like bear with me, but it makes it super easy to see what's going on. So let's keep it like that. So now we can see here that if I remove the alpha, so you see just the full background of the screen, let's say, which is red in this case. And then you have a view with a gray background and a dark black color, right? So that's what you see here. As soon as you apply the opacity, the view becomes transparent. Now, it's important to understand that this opacity is being applied to the entire view, right? And that's why you see still the text being there, but everything is transparent, right? So if we zoom in a little bit, we can see how the background, which is gray, now it's a little bit transparent, so you can see a little bit of the red going through. And the same happens with the dark text. But just to get the point across, let's see what happens if instead you remove the alpha for a second and we say the background is black, so the same color as the text. Exactly, as the color of the background and the text are the same, you don't see the text, you cannot differentiate it. And if we apply the opacity, well, the entire thing becomes transparent, so you still don't see the text, but at least you see through, right? But you don't see the text. Let's compare this now with what happens if we try to do the same in SwiftUI without thinking too much about it. I have here now the same in UIKit as in SwiftUI. I just have this view extracted here because I'm going to reuse it a bunch of times, so just that, but it's the same. I have a text that is black and a background which is gray, and both have the same opacity, right? But as you can see, it doesn't look the same. It doesn't look the same at all. Like the SwiftUI version, the text is darker than the UIKit version. You can see here how we have 194 value of red, and here we have 173, which means that there is less red, you know, so it's kind of like the red is not shining through that much. Why is that? So what we need to understand here is that when we do this in UIKit, we're applying the alpha to the entire view. So basically, it's kind of, yeah, this view has subviews, but for the rendering, that doesn't matter, right? Like it renders everything at once, and then it applies the alpha to that. And we can see very easily that, because if we apply the black here again, like we can understand how first everything is rendered, and because everything is black, you don't see any text, and then the opacity is applied. If we contrast this with the SwiftUI version, we can see how if we change this to black, you still can see the text. Why is that? Because the opacity, it's not applied after the fact, after everything is rendered and you see everything black. No. Here, this opacity modifier, it behaves as many of the modifiers that were used to work with SwiftUI, except that in this case, that's not exactly what we want, right? So in this case, what this opacity modifier is doing is going through kind of like through the view hierarchy and applying the opacity to each subview. That's why when you do this, right, you see less red, because the red in this case needs to go, like if you imagine that there is like the pixel color of the red, it needs to go from the background of the screen through the background of our view and through the text black, right? So at the end, the red has lost a lot of power, right? Instead, if we do it here, and put it back to gray, if we do it here, since it's just rendered all at once, there is kind of like just one layer. So the red just needs to cross one layer and that's it. And you can see, that's why you see more red here. And here it needs to cross multiple layers. So the power of that red, it's kind of gone, right? Of course, there is a lot of, mathematics behind this and graphic terminology that I could use, but I'm trying to keep it simple because, when I was going through it, it also took me a bit to understand. You see this change pretty quickly, but then how we can do it in SwiftUI, right? And just to be clear, let me change this to black again. So you can see that it actually, that's what's happening, right? If I change this to black and this to black, the difference, it's super clear. You don't have any questions about, oh, maybe, my screen is not rendering the correct colors or whatever. No. This is a completely different way of rendering things. So basically what is happening is that SwiftUI, as I said, it goes and puts the opacity on every layer. So in principle, it's the same thing as doing this, right? And then putting the opacity on the background, right? So it's exactly the same. So these two pieces of code, basically they are equivalent. SwiftUI is just applying the opacity as if this was a group of sub-views instead of just a single view. And we can actually see what will happen if we didn't have this double layering. If we just added the label with the opacity, you can see how the color here, kind of if you look at the text, it's more similar to the original one in UIKit than to the other ones in SwiftUI. And you can see it here pretty clear, right? So in UIKit, since there is one layer only, the red just needs to shine at this spot through the black of the text. So the red value is 194. It's the same that happens here. Even if there is no background, in this case, in this spot inside the text, the computation that needs to happen to calculate the color here is exactly the same here than here, right? So you can see how, again, it's the same as if it was only one layer. I guess the first question is, if SwiftUI is doing it like this, is it the real problem? Well, I will argue that most of the time, it may be not. If you're working with SwiftUI, you are used to applying these things on every layer, on every subview and stuff like that. So this is kind of what you expect. Even as we have seen, if we have a case where the background and the foreground have the same color, you still can see through that, So you could argue that it's kind of better, right? Let's put this back to gray so we have exactly the same colors. But what happens if what I really want is this? I just want to apply the alpha to the entire view, basically. I want first my view layout to be flattened and then rendered, and then I apply my effects, in this case, the alpha. Well, luckily for us, SwiftUI comes with a modifier to do exactly that. If we take the exact same thing we wanted to do originally, we just need to add a modifier here that it's called Compositing Group, right? And what this does is it wraps the entire view hierarchy basically in a single view. It unifies and merges everything, kind of it flattens the view hierarchy for the effects that are gonna come later. So this opacity is an effect, and instead of being applied on a per view or per sub-view basis, after this composition group is applied, it will just apply it to the entire thing at once, right? It changes the behavior of some effect modifiers. And now we can see how this actually looks like what we are expecting. And we can see how if I check the value of red, it's exactly the same value of red here than here. This means that we accomplish the same thing and the same functionality on UIKit just by adding this line here, right? And remember, if we want to remove that behavior, we just remove the line here and it goes back to applying the opacity to every layer, which you can compare and contrast with how we will do this in UIKit. So if we do all this process in reverse, now we say, oh, but maybe we want the UIKit version to do the same. Well, if you have access to every subview, it's kind of easy because you can just go to every view and apply the alpha. And here, because it's just the background color, we can just apply the alpha directly. So now we have this and the default SwiftUI as being equivalent. But again, one of the nice things of SwiftUI, it's this sort of thing, right? That you don't have to go this and change all your code. You can just apply a modifier and the behavior changes, And first, this was kind of surprising to me. I've used opacity a lot, but not in this exact scenario where I In this case, I had actually two views to compare, one in UIKit and one in SwiftUI, and things didn't match. So it's like, why is not matching? Well, here is the explanation. And it's actually very easy to go from one way of working to another. So kind of one of the powers of SwiftUI, even though the beginning it may seem weird. Well, so that's it for today. I hope you learn how SwiftUI deals with some modifiers like opacity and how you can actually use the composition group to group the effects and apply them all at once. Thank you all for watching and see you next time.